We are going to learn a new form of integration, a new way to take antiderivatives, and the goal is to learn a way to undo the chain rule. So with antiderivatives, we've already talked about the power rule, and we've already done some of the other functions like trig functions and natural log and e to the x. With this, we know that if we have a function that's a composition of functions, what that means is if we have something like h of x is f of g of x, we can take the derivative using the chain rule. So this, we already know from taking the derivative. But what we're trying to do in this section is we're trying to take the antiderivative. So we want to go in the opposite direction. We want to be looking at the derivative and find where it came from and find its antiderivative. So to do that, what we do, because when we had just finding derivatives as our problems, if we had something like, I don't know, 3x squared minus 1 to the fifth. If we were taking the derivative, we can identify what's inside and what's outside because there's really only two options. We have an inside, we have an outside. There isn't any clutter here. So if we take the derivative, we might have 5 times 3x squared minus 1 to the fourth, and then times the derivative of the inside, which we may have rewritten. We probably would have combined the 6x with the 5 just to give us a 30x times 3x squared minus 1 to the fourth. So now we need to be able to take something that looks like this and figure out where it came from. We need to take this statement and figure out that its antiderivative was this original problem, the 3x squared minus 1 to the fifth. And it's hard to do that because there's multiple things here. We have something out in front, we have a 30x, we have 3x squared minus 1, we have a fourth. There's a lot going on. So what we do with these steps here are meant to do, they're meant to simplify the problem. And I know that these steps look like a lot. It doesn't look like it's simplifying the problem, but I hope that once we do a few, it'll make a little bit more sense to you. So our goal is to rewrite our problem in terms of a new variable. So we take our problem here, the stuff that I've written on the side, it's all in terms of x. But if we can rewrite it in terms of a simpler equation, and that simpler equation, we just traditionally use the variable u to do that. I'm not really sure why, but traditionally we just use u. That new equation is going to be simpler than the original equation, and we will be able to find its antiderivative. So these steps here are ways of doing that. We're going to really focus on steps 1 and 2 first. So with step 1, we have to identify the g of x. And g of x, here, g of x is on the inside, just like over here g of x was on the inside. This we already have practice with. So we're going to identify that inside function, and then these steps here, we're going to take its derivative. So we take the derivative of that inside function. The reason why we do that, so we figure out what's on the inside, and we also take its derivative because we're trying to identify all the pieces of this original problem. So if this whole thing, this original problem, we're trying to identify the different components. I want to identify the inside function g of x, and I want to identify g prime of x. So that's what we're going to work on first. With identifying the inside function, with identifying g of x, we already have some practice with this. So if I look at this first problem and I want to identify g of x, what's on the inside? I'm looking for a few things. The parentheses are a real big red flag. Oftentimes the thing that's inside the parentheses will be the inside function. That's the same as it was before. So for this first problem, we're going to have u equals x to the fourth plus 3. Notice now we have something extra in the original problem. So I also have an x cubed in the original problem. We're going to find that that's going to be part of g prime. So if u is our g of x, if u is x to the fourth plus 3, and I take its derivative. So I'm going to do that over here on the side. So I have u equals x to the fourth plus 3. So du dx, the derivative of u, is 4x cubed. Notice that this is a multiple, 4x cubed is a multiple of this extra piece that we had in the original problem. And that's going to be pretty common. So we have u is g of x, and we find that in the problem as something that's inside something else. And then the remainder of the problem is typically going to be a multiple of g prime, a multiple of its derivative. Here, that extra part is going to be the number 4. We have a coefficient. So let's keep working with this, because what we need to do, we need to isolate the dx. So we are going to separate the du over dx. So I'm going to have du. And this I'm not sure if we've done before, but we are allowed to separate the du and the dx, because my goal is to get the dx by itself. So I'm going to have du over 4x cubed. And we're going to keep going like that on this side of the packet, or on this paper of the packet. So if we move to the second problem, and this is a cube root, kind of like that. That's not x cubed. I know that it typed a little bit funny, but that's a cube root of 1 minus 2x squared. So hopefully that helps you identify it a little bit more easily, that u, which is the inside function, and just the inside part, u is going to equal 1 minus 2x squared. So over here we take its derivative, du dx is negative 4x, and du over negative 4x equals dx. We try one more. So I have x cubed sine of x to the fourth. Here it might be a little bit less clear with trig. We still want to use the thing that's inside here. With trig, it's usually going to be whatever is inside the trig function. So I'm going to have u equals x to the fourth, and du dx is 4x cubed, and du over 4x cubed equals dx. So what you should do is try the second half of the worksheet, and pause the video, try the second half of the worksheet, and then come back to it. For the next problem, we're going to have u is 1 plus x to the fourth. So du dx is 4x cubed, and du over 4x cubed is dx. Moving down, I'm going to have u is 1 minus x squared. Du dx is negative 2x, and du over negative 2x equals dx. Last problem on this page, u is x cubed plus 2. Du dx is 3x squared. So dx is going to be du over 3x squared.